All right, so hi everyone, and welcome to today's discovery session. My name is Lucia, and I am the communication specialist for DeepSense. These sessions are meant to support students and businesses and other organizations with an understanding of how to use data, machine learning, and AI. Now, before we get into it, I would like to begin by acknowledging that DeepSense works out of Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people, and that this territory is covered by the treaties of peace and friendship, as well as the data that is being used is also coming out of Mi'kma'ki as well, that Amous and Amit will talk about. I'm just going to give a little background on what DeepSense is in case we have some newbies watching. So DeepSense is a project based out of Dalhousie University here in Halifax, Nova Scotia, but we work with universities and colleges across Atlantic Canada. We work with companies in the ocean sector who are interested in harnessing the potential of data and creating a smarter ocean economy. And then we connect these companies with the next generation of AI and machine learning and data experts, aka students like you. We work with these companies to create a project that best suits their data needs. And then we find a researcher and a student who can help execute that project as either a co-op or an internship, a master's project. We're really flexible with part-time and full-time. So we want to find what best suits the company and what best suits the students too, and bring those together. We've had past projects in data analytics, data collection, data visualization, data cleaning and processing, and of course, AI and machine learning. Projects could be anything from creating a deep learning model to track fish, or creating a prediction model for safe navigation in the Halifax Harbor, or even a computer model that can identify whale shapes from aerial images. So we have a wide range of projects, and we hope to introduce the ocean sector to students that didn't even realize it as an option. And so if you ever do want to work with DeepSense and work on projects with these companies, we definitely recommend you join our student pool. I'll post a link for that in the chat in just a minute. But basically, projects and internships and co-ops pop up throughout the year, so we don't usually post if we have an opening. We will go to our student pool, and that's where we're going to first look for students who have the right skills and are available at the time that the company would need them, and then we'd call them in for an interview. So make sure that your resume is up to date and rocking when you submit, and then hopefully you'll hear back from us in the near future if you get pulled out for an interview. Now, today's session, we're going to dive into a current DeepSense project that is with the company Integrasee, and it's a great example of what students do with DeepSense. So if you're interested in kind of seeing what a project could look like, this is a great one to start with. And it's a great example of the computer science and the ocean coming together. It's led by Amous, who is currently working with Integrasee on their Marine Canary project. And Amous is a PhD student in computer science, pursuing her degree with Dr. Malcolm Haywood at Dalhousie University, where she also did her undergraduate and master's degrees. Her main area of research is machine learning methods with log analytics in the cybersecurity area. And through her DeepSense internship, she's been working with Integrasee since September of last year. And with her is going to be Amit. He is the DeepSense data algorithms lead, and he actually first worked with DeepSense also as a student during his master's, where he completed an internship with BECOME, which is an acronym for Benthic Ecosystem Mapping and Engagement. And one of the goals of that project was to train neural network models for different supervised and unsupervised tasks. And in order to train such models, which are capable of learning the unique and varied features of seafloor mapping images from around the world, the team required a massive and unique image data set with representative images, samples from various parts of the seafloor. So that was Amit helped out with that project. But today, they're going to be putting their expertise and talking about Integrasee and the Marine Canary. And Integrasee is a company that DeepSense is working with, and they specialize in linking vision technology and animal behavior with machine learning and artificial intelligence to monitor water quality for a wide range of customers in the municipal, industrial, marine, and aquaculture sectors. Their innovative biosensor technology provides real-time feedback to help customers ensure compliance with environmental regulations, improve wastewater treatment, and protect public health, animal welfare, and the environment. So that's a lot of words in there. We're going to kind of break that down in our presentation. You'll get a better understanding what Integrasee does and learn more about their Marine Canary workshop. If you have any questions throughout the presentation, we'll be taking them at the end, but you can always drop them in the chat on the side, or you're welcome to use the question and answer box. Or if at the end you want to raise your hand, we can also unmute you and you can ask your question in person. But that's enough of me talking. I'm going to pass it off to Amous and Amit. You can start sharing your screen and we can kick it off. Perfect. Looks great. And you're muted, Amous. Are you talking?
Okay.
There you go.
Here we go. I think it just automatically mute me when I start the presentation. Somehow.
It's not that advanced, no.
Yeah. Okay. So Amit, do you want to start?
Yeah, sure. So I guess we already talked about Integrasee. Lucia gave quite a comprehensive intro for Integrasee. So I guess I'll just move on to talking about the Marine Canary project. So the name Marine Canary is derived from the phrase canary in a coal mine. Many of you have probably heard the story behind the phrase, but for those of you that don't, in olden days, miners used to take a canary or another bird with them into mines. This was because if there were any noxious gases or other harmful conditions in the mine, it would affect the birds sooner than it would affect the miners. And thus, it would give them a chance to escape before it's too late. So they were sort of using the bird as a biosensor or a bioindicator in that case. So it's the same approach for the Marine Canary project, but for the oceans or for aquatic systems. But instead of birds, we have mussels that open and close based on adverse environmental conditions. And with that, I'll pass it on to Amous, who will be talking in more detail about the project. I forgot to mention that, yeah, the project does address a lot of environmental issues, but unlike climate change and sea level rise, algal blooms are one of the environmental issues that don't get a lot of attention. So as we know, all organisms need nutrients to survive. Some of these nutrients are more abundant than others. Some we need in large quantities called macronutrients, and others we need in smaller quantities called micronutrients. Now, certain micronutrients like nitrogen and phosphorus can act as limiting nutrients. This means that, for example, the amount of available phosphorus or nitrogen in a crop field will determine how much yield we can get from it. So it's basically limiting how many organisms can grow in an ecosystem and by how much. However, having an excess of limiting nutrients in the environment can also be a cause for concern. Here you can see a picture of Lake Erie. And in fact, like something closer to home, here's an blue-green algae warring in the Micmac Lake in Dartmouth. So algal blooms can cause all sorts of bad things. So what happens is that when untreated sewage or organic waste from untreated sewage or other sources enters water bodies, it carries with it nitrogen and phosphorus, which creates a nutrient-rich environment where algae grow, die, and decay in huge numbers. And that depletes the dissolved oxygen levels in the water, causing hypoxia, and often leading into creating dead zones in the water body with virtually no aquatic life. So the aim of this project is to detect such adverse environmental conditions and hopefully start to solve them before it gets too bad. And with that, I'll pass it on to Amous.
Thank you for Amit introduce the background of this project. And now I'm going to introduce a little bit about the setup and the biggest advantage of it. So basically our project is set up in a box with 9 mussels and underwater camera. And with this, to be said, it's a very flexible setup. So you can put it anywhere. You can put it in the ocean. You can put it in the lake. And then you can just take them out and then maybe reuse them back into the ocean. And also, if you just want to use in an aquarium for the experiments, it's also very flexible. Next one, I was just going to talk a bit about mussels, about how it's going to help us with this project. So as we all know, like in the real life, you'll see that when you buy mussels and you go home, when you take from the bag and then you put it into the water, you'll see the mussels will just have just directly shut, even though like they might be open and stuff. And then you might we'll see it like when it's sitting in the water for a bit, it starts to being a little bit active, like opening the shell or something else. So it's a very sensitive creature, and especially like when you put in the water, it detects more than that. It can sense the temperature difference, the water toxicity levels, and or the carbon dioxide, or even the light. It's a lot of different elements can trigger the mussels to change its behavior. So while with this experiment setup, we use the features of the mussels and trying to help us determine what is actually the important elements or what things it can actually predict. With that to be speak, we want to observe the behavior of the mussel, but that needs to be a 24/7 real-time supervision over the mussels to actually make it to happen. But that's going to take a lot of labors into that. So the very biggest part of this project I like to talking about is the computer vision part, which is the AI to help automate this whole process without a human being watching, oh, is the mussel open or is the mussel closed? So I would like going to introduce a bit about my computer vision model. So here's the summary of the process. The first step will be prepare our training set. So with this we need to create a data set with images and labels with mussel open and closed. And then let's be our data sets prepared. And the second one is I was using a very popular computer vision model, the YOLO V5. And then with that, with our pre-trained, with our training data set, I'm going to fine tuning the YOLO with our training data set. And the validation part would be that some expert, say Lawrence, the CEO of Integrasee, he was watching the video footage that is actually predicted by the computer vision model and see if it's actually predicting the correct thing. Do we need to stop for questions here? Or should I keep going?
Amit, did you have any questions? Are you muted, Amit? You're talking, but you're muted. Can anyone hear Amit? Can you hear him, Amous?
No.
No.
Sorry, I was muted. Yeah.
Yeah.
So I think it would be helpful if you would explain object detection, what it is for the audience.
Oh, okay. We'll talk about that in the next slide.
Yeah.
So, well, I don't know how much background our audience today have about machine learning projects, but well, there's a very famous machine learning data set. It's called the MNIST data set, which is the handwritten digital numbers. And that would be a very first project that I was doing while I was taking the fundamental machine learning classes, is trying to recognize those. But the method we're using there is just a neural network with convolutional layers, trying to classification those numbers. But so that's like my first impression about object detection. But what we're doing here is a little different. Say with the first image I have there with my rubber duck, if we are using that model to do that, it's going to say, oh, it's a rubber duck. But what we want more for this project will be much more than that, is we actually want to know where the rubber duck is located and how many rubber ducks is there and where each of the ducks are presenting in this image. So I'm going to use this rubber duck demo to explain the process of the training process, just a demo. So the first is I have this training set with 5 images with 3 different looking rubber ducks. And then one of them will be using as my validation set. But I forgot which one did I use. But I used 4 of them as my training set and 1 of them as my validation set. And the second part would that be labeling the ducks. So, well, with the first one, I trying to make a square bounder out of the duck as well. That's a rubber duck, and I give it a label like that. And then with the second one, you may see that it's actually overlapping with each other, and that's what I actually want it to be, because with our mussel project, you're actually seeing the mussels kind of fighting with each other, they may overlapping with each other, and that's a very it's kind of an issue, and we need to solve it because we can't control the mussels don't move, because we want them to move to actually see what's happening.
Okay, Amous, could you give us a snapshot or an idea of what the data actually looks like, or what we're actually feeding into the model to train it?
Okay, so let's say for this one, we actually have a label file along with these two images together to fit into our model. And what's in the label file is the X and Y axis along with the length from the X and Y with the box. And we're passing that along with the image. So when the model receives the image and the label, it can matching them together to make predictions and the training process going.
I see. Thanks for the clarification.
So, well, the next step would be training, and I'll just going through the different measurement and see what's give a little bit explanation of this one. So the left side is the training box loss, training object loss, validation set a box loss, and validation objective the loss. So with this ones, we want number to be 0 because the loss means the error we are actually seeing from the real labels and the predicted labels from our model. So we want the error to be as small as possible. So, well, from these photos, we can see if you know visual machine learning, we probably want to train it a bit longer. But if we see on the right side with the matrix with the precision and recall, which is basically just our accuracy values, it's actually got to 1.0, which is 100% correct at the 150 epochs. So I just stopped this training because I think that's good enough. And then I want to show this little bit of validation on the rubber duck demo would be another 4 rubber ducks.
Just to interrupt, Amous, could you quickly explain what, could you just go back to the previous slide, please? I just had a question. Okay, so what was the graph in the middle one? I think it said training / CLS loss. I don't know what that is.
Oh yeah, I didn't use that as my measurement.
Oh, I see.
Well, because that's just it's constantly there, so it's just doesn't really. I think that's for the classification one, because well, if with like our open and closeness, that might change. But this one we only have one label, so it's not really saying, oh, we are recognizing this rubber duck as a rubber chicken or something like that. So it won't be. It's just constantly there. Does that make sense?
Yeah.
Well, I think I saw a question in the chat.
Yeah, we can save it to the end, or you can answer it now. Up to you.
Okay, I can also say that.
Okay.
Does the company provide the labeled data, or do you guys create the labeled data set? Well, the company didn't provide the labeled data, but actually Lawrence helped me a lot while trying to label the data. He would send me the video footage. It would just be mussel videos. But in the beginning, I'm not a biology. I don't have that much biology or marine biology knowledge to actually know if the mussel is open and closed. And so Lawrence, in the beginning, we spent like 2 weeks to see when the mussel is closed and when the mussel is open. And he will give me examples and train me first. Does that answer your question? Okay, good. So move on and see the validation set of my RoboDuck demo. So, well, in this one, I have 4 ducks here, and it didn't show in my training data set. It's a 4 different looking ducks. Like we didn't have a duck with a sunglass, or we didn't have a duck with a parroted head, right? But my model still did well in this one, and still able to predict or to recognize the duck. And so there's like small numbers right next to my labels here. It's RoboDuck 0.93, and there's RoboDuck 0.94, 93, 91. That means that number is actually the confidence level of the model, saying how confident this model is actually saying, oh, this is a RoboDuck. And with this to be 90% and up, means it's like it's super confident to say it, which is a very good thing, because that's that number. If you are using YOLO v5, I'll be actually cautious about that one. That's a very good indicator to separate different stuff. And well, now this is the end of this demo, and let's see some of my real prediction videos.
Looks like there are a lot more instances when the mussel was open rather than closed, or at least from the predictions.
Yes. Well, so yeah, we actually had some problems with the close, because there's, as you can see from the video, there's like not much close instance, and then that will create an imbalance to the data set while I was doing the training process, and that's like because it's just not really confident to say it's actually a close. While I was training it, I think that my close confidence is at like 0.4 or something, 0.5, so like 50, less than 50% confidence. So that's pretty low. So I had to go back and forth and put in more close instances just for the training process. Well, I'm going to play this again, and I want you guys looking at the bottom left one, because I think that's a very interesting mussel. You see, there's like a tongue, like a tongue, just keeps sticking out and trying to figure out what's going on. And then it's just our most active mussels. If it's close, it'll be the first one to close. And that being said, it's there's 9 mussels, and each individual is very different. So that's a little bit challenging too, because, well, like you don't look the same, right? And then if we're just trying to recognize if it's a mussel or not, that would be easy question. But the trick is, how do you know if it's open and closed? So with that, we have to keep feeding in more models and more angles of images into it to let it train.
I think we have a question from the audience as well.
Yeah, Jade is asking if the video of the mussels from the side, could it affect the model's prediction accuracy? Because the videos are generally, she sees, are being filmed from the front.
Yes, so we actually have some side profile in our training set, but I didn't show them because I don't want to show everything.
How many different angles do you have, like, of the mussel?
So
mussels?
we have mostly it's from like the direct way facing it, and then we have some like on the side, and then we have some different angle of or different type of camera, and it's like give it like more wide view of the mussels, which, well, in the beginning, if we keep looking at the same, that's going to cause another problem. It's called the model overfitting, because it's just the same angle. So it's not really learning. It's just trying to memorize the mussels behavior. So that's not what we want to see. We want to be able to see it from anything, any environment, any light conditions, or from the side, or the front, or even the back, or even the top.
Great. I think that answers your question, her question.
Nice. So since your model is trained on images from various angles, it should be able to like correctly predict open and close from like various angles as well.
Yes.
So Amos, how many images did you have in this data set that you've created?
I have 1,500 images, or more than that, at least 1,500 images, and with each of them we have 9 mussels, 9 instances in each images.
So how long did it take you to label those 1,500 images?
Around 2 months, because I have to go back and forth to tune the model. And as we said, we did have some problem because there's a lot of open mussels, and I have to go back and manually throw in more closed instances in there to actually help it learn what is actually closed. So that's why it's spending so long to get this whole process going.
See. And also, I think another interesting question is like, why 9 mussels? Why not just 1 or 2 mussels?
Well, because remember what I said, there's the little guy here on the bottom is very active. Yeah. And well, comparatively, I think this guy is not. The guy on the right side on the bottom is not. And sometimes it's just not very obvious, and it doesn't really react as much as the guy on the left. So yeah, we want those variety of the mussel behavior to actually have the majority vote for the success.
I see. So since like individual behavior varies so much, we're sort of going like taking an average, or like going with the wisdom of the crowd.
Yes, that's correct.
Okay. Thanks.
Okay. I'm going to talk about the next step. So with our computer vision model build, we actually know what is open and what is closed. The next step is we're going to link that to the real-time data. So we have this setup in the with the Cove. It's called Mars. Where Amit is going to give more introductions on that. But basically, that thing is a real mechanic sensor, and it's going to give actually the real data. And then what we want to do is trying to link the behavior with the biosensor, our mussels, and this mechanic sensors, and see what's actually affecting each other, and what is happening going on there, and what is the mussel really capable of doing. I'll pass on to Amit so he can introduce a bit more about Stellar Mars.
Yeah, so the Stellar Mars is a multi-sensor platform that's located in the Halifax Harbor. So what it does is it helps the Halifax Port Authorities, but it's for our purposes, it's mostly like research purposes. So it has a bunch of different sensors for recording temperature, water toxicity, salinity, that kind of stuff, pH. So now that we've been able to predict mussels opening and closing using a computer vision system, we want to link that to if there's any relationship with that to adverse environmental conditions, and that's where the Stellar Mars comes in. So we'll actually be able to observe the mussel behavior and the measurements of water quality that are taken by the Stellar Mars, and combine those two together to address different kinds of environmental issues. Yeah. With that, I think we've covered most of our content. If there's anything else, Amos, that you would like to add?
No, I think that's all. It's our question session now.
Sure.
Cool. So, well, one of the questions that we have is from Sophie, and she's asking, what made you interested in computer vision in the ocean industry? Like, how did you get involved, or why did you decide to work with Integrasee?
No. Okay. So what I'm doing at school is a lot of them is just basically natural language processing with cybersecurity data. And I'm just always surprised, and I'm always like into seeing what AI can help people achieve. Right. And well, I know there's the very heat thing is the ChatGPT, and the open AI have a lot of projects. And well, and I'm in Halifax, right? I just want to see like what AI can actually do and help with the marine biology side. That's very interesting to seeing that, or like to, like exploring different things. And I really like going to aquarium. So that's another thing.
Is your favorite animal the mussel?
Or I like eating them.
Muscle
Did you name any of the mussels the 9 mussels that you look at? Do they have names?
No, they don't. They just got the bottom left guy.
Should call him Fred. Give them
Fred?
names.
Maybe we should do that next.
That's one of the next steps of the project. But if anyone has any other questions, feel free to drop them in the chat or in the Q&A, or you can raise your hand if you want to rather talk out loud and we can unmute you. We have Jade asking, what is the purpose of identifying whether a mussel is open or closed? They missed the beginning of the presentation, so maybe review the whole, like the canary in a coal mine part.
Yeah, so the name of the project, the Marine Canary, is based on a phrase, a canary in a coal mine. So I don't know if you're familiar with this story, but in olden days, miners used to take canaries or other small birds with them inside mines. And if there were noxious gases or other harmful conditions in the mine, it would affect the birds sooner than it would affect the miners. So that would give them a chance to hightail it and run. So they were using a bird as a bioindicator, or so it's kind of the same approach for the ocean, but instead of birds, we're using mussels. And mussels tend to close down whenever they don't feel that the environmental conditions are conducive for them. So that's why we're trying to detect whether mussels open or close, because if it's open, it means they're happy, sort of. And if it's closed, that means adverse environmental conditions. I hope that answers your question.
Oh, there's another question here.
Yeah, we have in the chat. Was there a specific reason for choosing mussels for the study? Oh, I don't know do we know the answer to that? Why they chose mussels?
Yeah, I think that's a question for Lawrence. But like, if I were to answer that, it would be like this, the answer that I just provided. Like, mussels are known to close down when they're in adverse environmental conditions, so they're a good candidate for this kind of study. There may be other organisms that are more or less suited for this, but these are the only ones I'm aware of.
Yeah, and I'd also just add probably because availability. There's probably other mollusks or bivalves or shelled creatures that could react, but these ones in the environment they're in, like oysters or scallops, don't attach themselves to things, so it wouldn't be a conducive environment. So I think these guys are just better because they're being attached to the Stellamaris or the metal grid, which you can't really do with another bivalve as easily. So there's probably a lot of different reasons that went into choosing them. And then they're also pretty readily available, and they're found in freshwater. So you can replicate this with freshwater species of mussels too. Another question, do you maintain the project for a long time? Example, continually improve the accuracy of the model by adding more data and changing model architecture, or is this just a one-time thing?
Well, I would say it's a long time wrong. So like in those 2 months, we're trying to get this model down. I will add some data in there, and I will trying to tune the model. And then, well, a lot of neural networks is just weights, right? And I will just download the weights file. And then when storing more data, I can reuse the same weights file. So at the start point, and then I just keep tuning it to what I want. So yeah, just a lot of back and forth to improving the data. It's not really a one-time thing. Well, with the rubber duck, it is one-time thing because that's very easy model.
Because that was just for a demo, right?
Yeah.
Yeah.
Yeah, so the goal is once Amous, you're done your project, Integrasee would be able to continue and maybe bring on other students to continue the work. I don't know the future, but it's definitely ongoing.
Yeah.
Any other questions anyone has? Or anything we might have missed? Seems pretty quiet. Yeah, if we don't have any more questions, I think we can wrap things up. So thank you both for coming in and talking about this project today. I think it was really insightful and it's really informative and helpful for maybe future Deep Sense students or anyone interested in this kind of work. I think they're able to learn a lot from today's presentation. So thank you for taking the time and even a little last minute, but I'm glad we got it in before you left the country, Amous. So thank you. And I dropped the links in the chat right now for the student pool that I mentioned earlier. And we also have a mentorship program called STEM Connector that if you're interested in connecting with folks who are working in the ocean sector or with other students as like yourselves, make sure you sign up today. It's all free. It's a flash mentorship program, so you don't have to meet the same person once a month or every other week. It's kind of one-off meetings that could be done virtually or in person, whatever works best for both of you. So make sure to sign up for that. We also have other discovery sessions that you're welcome to explore. So I'm going to drop the link to our YouTube playlist in the chat, as well as our social media. So we have a discovery session lined up for the end of February, and then another one ready for March. And so I'll be posting those on social media once we have all the information ready for them. So make sure to follow us on Instagram, Twitter, or LinkedIn. We also have the Ocean of Data Challenge starting in February. So this is a great way to kind of put your skills to the test and work with some natural language processing. So text data and answer an overall challenge question about how we talk about the ocean online. So I'll be posting that on social media today. So look out for that. But yeah, I think we're good to wrap up. And a big special thanks to the rubber ducks. They were very important to today's session for sure. I like to get a shout out in the slides. Amous and Amit, do you guys have any last words before we wrap up?
No, thank you for the opportunity.
Amous, you're good? Awesome. Well, thanks again, guys. I hope everyone has a great Friday and a great weekend. And we'll see you at the next discovery session. Thank you.
Thanks. Bye-bye.
Bye.